All right. Well, thank you everybody for coming to DevSecCon Dallas. So sorry for the formality, but we are streaming. Hopefully we have a large crowd on there. But my name's Kenny Parsons. I'm the chapter leader. That doesn't mean anything super important. It just means I was a nerd and I wanted to find a group and there wasn't one, so they asked me to lead it. So I'm a senior regional engineer for Trace 3. Like I said, I found the group trying to find a resource for myself and there wasn't one. So Sneak reached out to me and asked me if I wanted to host this group. And so obviously this is the first meeting and we're hoping to grow it. So obviously please share and all that. The ISSA group, the North Texas group for, the educational student group, we're trying to get in with them too. So if you know of anybody there graduating or studying, that's, those are the kind of people this group is made for. Let's see. This community, actually, the community is the core concept of what I hope for this group to be and what we're experiencing. And I kind of dubbed this meeting like Founders Day Founders Meeting because I really wanted this y'all to know we're starting something new here. We're starting something new in this area that we really need. Like I said, I found this because I was looking for a resource and there wasn't one. So hopefully you all can take ownership in that. You know something that somebody else doesn't. We would love for you guys to share whatever you're learning, whatever you're practicing in your workplace, learning on your own. We need you to share as well. Be owners of part of this group. So it's a community group. We're not led by a bunch of, money and professionals that are, we pay a lot of money for this. No, this is community led and we have great sponsors who are helping pay for food and provide facilities and things like that. But this is led by you guys. So we really want to make this available to you as well to participate in the community. So in just a second, we'll have Charles Brewington come up. I'll let him introduce himself. But a quick announcement, we do have DevSecCon 24, which is a 24-hour rush coming up soon. So you can find all the details in the Discord. If you're not on there, let me know. I can get you connected to that. So DevSecCon, like I said, is powered by Sneak. They are very gracious and help us out with a lot of infrastructure. So big thank you to them. And then the sponsors for today and for today's food is Sysdig. So huge thank you to them for providing the food and for Charles for coming in with a great topic. And so without further ado, I'll turn it over to him.
Thank you for the introduction, Kenny. So yeah, and just like you said, real glad that you're getting this started out so that we can really get some community around these topics. But I'm Charles Brewington. I have been with Sysdig for a little over a year and a half now, coming up on 2 years. And really happy to be here and just talk about really open source Falco and the applications of the tool in DevSecOps, to use the buzzwords on the screen here. So getting into it, let's just kick it right off. Wanted to start really with the philosophy behind security, right? We won't spend too much time here. I think this is things that we get, but it's important that we mention it as we kind of set up what Falco is, what it's about, and why it came about. In the past, when we were in data center land, right, it really was like a castle. All of your infrastructure was in one place. If somebody were to breach it, they had to breach the walls, right? So we could set up a nice little moat around it, let the bridge down as we need to, bring it back up. One way in, one way out. We know what's going on. That's just not the case in the cloud native landscape. We went from castle to more of circus, and I'm laughing because there's a circus outside, but that's neither here nor there. That's neither here nor there. But we went to more of this landscape where we don't have a clearly defined perimeter, right? We're going to start using, let's say, open source tooling in our environment. We're going to start using third-party applications. The workforce is working from home, so everybody's got to connect in from somewhere else. It's just become a place where you've got a lot more different vectors for attack coming at you, and a lot larger of a blast radius if there is a compromise, right? You have to have a way to not only secure the walls, secure what's going on outside of the environment, the ways that you get in, but also to know what's happening inside of it, right? It's just not as simple as it used to be. To skip to the bottom there, you have to be able to detect unusual activity, right? To kind of further that point, right? The philosophies behind security, the walls, that bridge, the moat, it's a good lock, right? These days, we need the security camera as well for the reasons that I just mentioned. We just cannot secure an environment by simply watching the outside of it, right? You got to be able to identify the intruders, identify the suspicious behavior, and more importantly, in real time, have some alerting capability and have some response capability as well, right? You got to be able to take immediate action based on what it is that you've seen. And, with all that set up, right, this is where Falco comes into play. Created by Sysdig, but more importantly, really going back again to the roots of Falco, our founder, Loris Dejwani, was actually the founder of Wireshark as well, one of the co-founders. And that same principle of having visibility into what's going on from a network perspective, he said, well, why don't we do this for all of our workloads, especially in a microservices-based world, especially when we're moving to the circus and away from the castle? We need to have visibility into that environment, and that's specifically what Falco was here to do. I'll say this a few different times, a few different ways with a few different examples, but Falco in and of itself is a way to take some streamed source of data, right? We'll get into a bunch of examples about that, and then identify what it is that we've just seen, right? As an intrusion detection system, you could even think of it as a query language, and we'll get into just what I mean by that in a second here. I kind of started down this path, right? What is Falco? It's all about doing those detections. It's all about making sure that we know what's going on inside of the walls here. Observability for endpoints and cloud infrastructure. I mentioned how, Falco is a way of taking some stream source of data, identifying what it is, and responding off of it afterwards, right? So that can be for a bunch of different endpoints. Let's take a microservices-based environment. Let's take Kubernetes, for instance. Falco could be installed using Helm, which is what we're going to see here today. Falco can be installed. Just have it listening to the system calls on a given host and understanding what it is that we've just seen and going from there. We can apply that same concept to things like a Kubernetes audit log. We can apply that concept to various CloudTrail audit log. I use the AWS terms, right? But we can apply that to the audit logs for the various cloud providers. Again, any stream source of data, we can use Falco to determine what it is that we've just seen, and we have, you'll get to see that in action here in just a second. Built on top of eBPF, staying on the Kubernetes focus here, I kind of talked about how it works already. Installed as a daemon set, just make sure that we have one agent or one, I'll call it a Falco sensor in this case, one sensor that can, again, ingest that stream source of data, do so in real time, understand what we just saw. eBPF is our way of doing that in a containerized environment. It's basically just the philosophy there was, again, the same one that we had with the with the network inspection using Wireshark, right? It was, this tool has to be built to support this environment. It's got to stay out of the way of the containers. We can't rely on the containers being there. And again, that's why we're built on eBPF there, or why I should say Falco is built on eBPF there. Forgive me if I say we. It's all open source Falco here. And of course, it's integrated directly with Kubernetes. I talked about how Falco can be used to respond to the Kubernetes audit log as well. Lots of different ways, lots of different endpoints that we can plug it into. To give an example of what it looks like when Falco has detected something, right? I've talked about how it's an intrusion detection system, stream some source of data in. We're going to use Falco to determine what it is that we just saw. So this is basically an alert that's responding to a system call that fired on a host that had a Falco sensor, reading to it. And basically what it's done is it's seen that, hey, netcat was running inside of a container. It's able to identify that system call, relate it back to that specific container that it was inside of, and let you know exactly what's happening inside of that environment. Again, having a tool that's purpose-built for these type of microservice architecture is a very important thing. So again, just an example of one of the alerts that you get with Falco and the information that comes with it. Lots of context for the environment it's a part of. I've talked a few different times about the various sensors. I called it an agent, right? Like I said, right? We ingest some stream. Falco ingests some stream source of data and identifies what it is that it just saw. You could look at that and think about that as the events. Kubernetes audit logs, system calls, that could be CloudTrail, that could be Okta logs, VPS DNS flow logs, right? Any stream source of data, and then we're going to apply the rule set on top of it, right? We're going to tell the sensors what they need to be looking out for, what they need to identify and then push that out in alerts to us, right? That's it in the most basic sense, the concept there of what's going on. And then you kind of blow that architecture out, right? We just looked at it in a kind of an isolated space, right? That would be one server, that would be one node, that would be one, entity that it's listening to. But then we can aggregate all these. I mentioned CloudTrail, I mentioned the audit logs, I mentioned the system calls, the various other sources of data, right? Aggregate these to a collector. That could be a SIM tool, that could be an S3 bucket if you wanted it to. However you want to strategize around that. But, the point is to have these all in one place to make sure that we can respond to these alerts and really have all that visibility that we're looking for. Falco is a tool that can be used to handle all of those use cases. And we will get into how in just a second. Beyond system calls and containers, I've talked a lot about this, just how it can plug into basically any stream source of data. And it comes down to these Falco plugins. You'll get to see in just a second when we start getting into a little more of the code aspect of it. You'll get to see the YAML that makes up the Falco. Basically, we can write a library for each stream of data and make it work. I gave some examples of flow logs, DNS flow logs, so on and so forth. But the idea was really just to create a tool that could be used across the surface, across the various landscapes, to have one single way of kind of doing it, but have it apply in multiple different contexts, aggregate it together, and have that visibility and control over it. So lots of things that we can do with Falco. It's very flexible in that nature, right? And we'll get to see what that looks like here in a second. A few different points to make about it. Really, the open source roots behind it, especially, it closes the talent gap. What do we mean by that? It's, when you're using this, when you're inundated with it, it's not a black box. Falco is going to be rules-based detections. You're going to understand why each one of these alerts is fired off. And it really does bring a level of understanding just using Falco, right? So it does end up closing the talent gap inherently by using Falco. You're going to be learning this stuff. And also, with such a community around it, right, it's very easy to find the support that you need when you're trying to get up and running with it. One thing that I don't think I can hear in any of the slides, it's approaching 70 million downloads. And it was donated to CNCF, I want to say 4 or 5 years ago. Don't quote me there. But it was donated to the CNCF quite a while ago, and it's expected to graduate very soon. I want to say this month, but again, I don't want to quote it on that, but it should graduate very soon from there. So again, mature tool closes that talent gap, meaning that we have a mature community around it as well. Provides rules transparency. I mentioned that it's a rules-based tool. You're going to see exactly why an alert fires off. We won't hamper that point anymore. And then innovation. This just comes again with open source tooling, just the fact that there's so many people driving this and enhancing this and working on it, right? If I get to the next slide here, we can see, a lot of the contributors behind it, right? Samsung, Volvo, Apple, so on and so forth. A lot of the reasons and backers for why it's going to graduate pretty soon here. Again, it's all to say that there is a significant community here supporting Falco to really kind of build this up, and it's approached maturity here. So really cool tool. This is the last, a few more slides so we can get into some more of the, practical application of it. You can see what it looks like. But just wanted to include some resources here for everybody. Just falco.org. Again, open source community. There's a lot of resources out there to really get started with it. On top of that, we also run workshops. So you'll see in a second here what it actually looks like. But we also run workshops for anybody who wants to get hands-on, who wants to learn more, who wants to integrate this. And we have a few coming up. So I'll stay on the slide for a little bit, and we'll come back to it at the end of things. But if you're in these cities and you're more curious about Falco after this, then please come on through. We'll have more food, and we are, happy to, continuing to build up the community here. This is more words saying what I just said, right? Okay, workshop, we want to get as many people in here as we can to, again, really build up what we're about and kind of spread the good word there. All right, that does it for my slides. Let's take a quick look at just an implementation. So I have a pretty basic, I have a pretty, okay. Ooh, I hope I can. There we go. Good old light term. Okay. So I have a pretty basic implementation here. If I go and just do this, we'll see what I have running in just a second. Right, so it's a small cluster. Again, just 2 nodes here. I've got Falco running as a daemon set that I installed via Helm on both of them. And you'll notice Falco and Falco site. I talked about having integrations and having a collector, right? An endpoint that we send all these events. Sidekick is going to be the tool that integrates with other tools and sends those events on to be forwarded to wherever we want them to be, right? So Sidekick is something that you would have to enhance the implementation that you have here. So that's what we have running here right now. And all I'm going to do, I don't have anything else running in the environment, right? So that's in that's the Falcon namespace. All we're going to do really quickly is run a cryptominer, right? So let me go ahead and do that. And I just have a deployment set to deploy exim and we can take a look at that in just a second. All right. So now I've got exim running. I've got my cryptominer going. And just so we can see what that looks like. Oh, yeah, you'll get to see in a second right here. They told me do not do math logs. All right, so here's our cryptominer. To answer your question, I am making absolutely nothing for myself. I have been a donator as long as I've been running this. So somebody's doing something here. They would be, at least if I let the connection go out, which I haven't been. In any case, so this is the cryptominer, so you can see it running inside of the environment, even if it's not connected anywhere. But there it is. So one cool thing that I can do already, since I already have detections in place for detecting these things running, is what I can do is I can take a look at the. Oh, sorry. This is live. All right. I can take a look at the Falco pods and look at the logs in there, and they're immediately going to give me some information about me running that cryptominer here, right? So let's do this. All right. Ah, yes. So in the log here, what you're going to see, focus on the bottom. We'll ignore most of that's going on up there. Forgive me, hard for me to highlight this, but on the bottom here, right? Exim cryptominer detected. And it's going to give me some information about that, right? It's going to tell me which container was inside. If you look right here, I've got the container ID. So I can see the container in there, the time that it happened, so on and so forth. Some of the initial detections about what's going on. And this is determined based on the rules that I've fed it and told me to detect on, right? So we've got that going right there. The other thing that I set up, and you might have noticed, you might have heard some alerts come through. I actually have this feeding into the Discord server. And it looks like it is. So right now, here's 6:47. I also have exim cryptominer detected, so it's giving me the information about that alert, the container ID associated with it, which rule it tripped off, so on and so forth. And I could go even further and do a little more than this, but what I want to do is show you the configuration behind it next, so you can kind of see what's going on there, and then get a little more about what's happening behind the scenes there. So like I said, This is my very incredibly basic configuration. This is all based on, yep. Come on. Work with me. Command scroll. It's yeah. Did not think about this part. Let me see if I can't make it bigger. Mouse wheel holding control. If only I had a mouse. That's the problem. Yeah. Yeah. Hey, it does not want to. Gotcha. And maybe. Okay. That's all right for everybody. Well, we can do two. Yeah, we can do two. All right, get out of here. Fantastic. So right here, Falco Sidekick. So this is all based on the Helm charts. It's all the daemon set. I only picked out a few things I needed to turn on. UI to make sure that we can stream the events. Falco Sidekick, where I have this Discord integration set up, and you can plug in a significant amount of tools to Falco Sidekick. Lots of integrations coming right out of the box there. From sim tools to S3 buckets, anything between. Let me know what you're curious about. We probably have one for it. And then finally, this custom rule here. So I only added one rule to detect the cryptominer, and this one is very literal. A process was spawned. So if you take a look at the condition, this is where Falco looks like a query language, right? A process was spawned, and that's actually making use of a macro. I'll show you what that means in a second. And then the process head of rig, the args inside of the process, contain exim rig, right? So this is a very literal rule to do this detection. But I wanted to go ahead and add it in here just to show what a custom rule looks like, right? And what we're going to be doing there. You've probably noticed the tab up here next to the settings that we have to play around in for a second. But I have other examples that kind of expand upon this. I wanted to use the most simple literal one just to really see what's happening. And then we can dive into some more concrete, I'll call them enterprise examples here in a second. So again, all of this is Falco, right? Falco is going to be a bunch of YAML that you're using. And in here, right, I have lists and miner ports configured. This is, again, based off of a blog post that we have on the on falco.org. Again, great resource to learn more about this stuff. But we have lists here and ports that correspond with the talks we've seen in the field, right? All of these right here, they actually ship with Falco. There is a verbose rule set that ships with Falco, and again, that can be found on the website. So these are included in here based on what happens in a crypto mining attack and what we see in the field. So those are lists, macros. Actually make use of said lists, right? We've identified certain miner ports, we've identified certain domains that are used with crypto mining. So what we can do here in these macros is say, hey, I saw a system call, it's got information coming from it, it's fd.s. It's talking about the certain port that's coming out of. It's over 443. Let's check that again. Let's check the IP that it's going to against these other miner domains that we're aware of, right? We can do the same thing for AD and against HTTP miner domains that we're aware of. And then finally, just going over any of these other ports that you see, right? Let's check them against those ports. Let's check the system call that we're reading against those ports, see where it's going, start to make determinations. All the rule set that we have, all based on the knowledge that we've accrued up to this point. So the basic rule that I had on the falco.yaml up here to the left here, all I did here was kind of add, network activity. Right? It's the same looking for that specific process. Again, very literal there. And I'm kind of skipping to the one down there, but now we've added these miner pools, right? Hey, is it inside of miner pool HTTPS or miner pool HTTP, right? And then it'll apply this condition in place of a macro, so on and so forth. You see how Falco starts to become like a query language, right? And the various ways that we can start to use it and apply it. So that's an example with a rule that I had built out there. Down here is probably the way that I would recommend using this in more of a production environment, right? Looking for malicious binaries in general. You get a description about it. That's the type of thing that pops up in the notice that we'd seen earlier. And then the condition is again where it looks like the query language. Certain things inside of the system call that indicate a new thing just came up. We're going to add into the environment, a change was made. Is it inside of malicious binaries that we've identified? Once again, is the process, the name of the process in binaries that we've, identified that are issues, right? And those and those lists, the rest of that macro is right up here. So again, you can see exim rig included in here, as well as many others that also correspond with miners that we've seen in the field. And this is, again, just specific to crypto miners. Very easy for you to add anything else here, right? Right, it's very easy to configure these things, keep them up to date, keep your rule set going so that you can stay up to date with these attacks, right? And this is, again, we're leveraging the community, leveraging, the fact that so many people are running this and utilizing Falco and improving the rule set, right? We kind of showed the NASCAR slide. Exactly. Yeah. So we got a question in the room asking about the nature of these lists. Are they global? Are the macros global? The answer is yes. So in fact, if I come over here to my own deployment to just kind of handle that point, I'm glad you made it. I'm actually using one of the macros that exists in the default rule set for, Falco in my own custom rule here, right? So you do not have to configure these multiple times. One list with all the binaries that we, well, you could think of it in a few different ways, right? It could be the binaries that we've identified as issues, as problems, as we don't need to see this again. Or you could go the other way and say, these are the only things that happen in the environment. Anything else is container drift. And just like a query language, simply and not, in binaries that should be okay. So there's a lot of flexibility, a lot of ways you can apply Falco to your own infrastructure. Go ahead. Yeah, no, please.
Less disparity, but I don't want to see it all the time. But I might want to couple another low, medium, whatever together and building block those together.
So rules cascading off of other rules, that one I do not believe we're going to be able to service for you there. However, it's also all come with priority warnings. Some of them could be as simple as a shell if detected. Others can be more. What should I say? They're going to look for more parameters to get more specific about the type of detection that comes off of it. So basically, if you look at the rule set, you'll have higher indicators of compromise that add arguments to more basic things. And that'd be kind of the way that I'd answer that question and, have it so that I can get information with Falco, but also know when I have a true high indicator of compromise coming through as well, right? It'll be in the way that you kind of set up the priorities, how you make it specific to your environment, so on and so forth. Yeah, exactly. And Sidekick can forward them right on there. So that's exactly how it would work. You want to integrate Falco to your environment and really tailor it to your specific needs. But this is, as far as I wanted to go with the example here. The last thing I was curious about doing was kind of making a ChatGPT write a Falco rule. That is something that it is very much capable of doing here. But before getting into any of that, are there any other questions, as we kind of get to see this? Those were good questions that you were asking, right? Just about how Falco works, or really its place inside of an environment or the nature of it.
Yeah, there's one question. Can Falco be configured for traditional VMs or bare metal? So we're not in a Kubernetes environment, but rather in a VM environment.
Absolutely. Coming back to kind of how the sensors work, if I'll go this way for you real quick. If I go back to kind of how these sensors work, or even right here, beyond system calls and containers, the reason to listen to the system call is so that we don't have to rely on the container being there at all to have visibility into what we just saw. Container might be there for a week. Container might be there for 10 seconds. We need to know what happened in that period of time. So since Falco doesn't rely on tracing, it's listened to the system calls, it stays out of the way of the workload. It makes it really easy to apply it to not only containerized environments, but bare metal Linux environments as well. Right? Just run it as a service. Its system calls are going to be firing off in either case, and it can respond to them either way. So some of the largest applications of Falco, in fact, are going to be non-containerized bare metal environments. That is a fantastic question. Any others? Y'all want to see ChatGPT make a rule real quick?
Absolutely.
It's oh man, when I restarted my Chrome before this, it kind of took it away. But either way, I will go ahead and let's do it. Let's go ahead and do it. ChatGPT. Oh, come on. All right. Fantastic. So, kind of along the lines of okay, yeah. Kind of along the lines of it being an open source tool means it's really easy to just have things like this, learn how to do things. So I could say something like, write me a Falco rule to detect a cryptominer. It probably will use that too. Exactly. So let's see what it comes. There it is. There it is. I probably play around with this too much. So I've actually done this a few times. If you've used ChatGPT, you know it'll come up with different things. One rule that actually came out of it tried to detect CPU utilization as well, right? So it was interesting, CPU and GPU utilization. That might be this chat right here. I might have saved it up. No, I didn't. Oh, okay, this one goes a little bit into it, right? Looking for CPU utilization on top of it, so on and so forth. But the thing is, I asked it the same question, right? A Falco rule to detect crypto. But in any case, this is again just to just a little bit of fun here, right? But you can see the application of Falco, how flexible it is in its applications, and probably most importantly, how easy it is to get up and running with it in the first place, right? I didn't show installing, the daemon set, but it's as simple as a Helm install. You can straight to falco.org, and you've immediately got so what I'm looking for, guidance on getting started.
So I'll ask you a question for you to repeat it. Can you configure, is Sidekick configured per deployment or per pod, or can it be for the whole, like per node?
So it's going to be configured based on based on your deployment there, right? So if I come back to my very basic deployment of Falco, wherever this daemon set gets installed, Falco Sidekick is going to be configured to set up those alerts with the minimum priority being warning onto the Discord and forward it on there. So it all depends on where you install your daemon sets and how you install your daemon sets. In that way, it is, yes, as configurable as you would like it to be based on where it's going. Did I repeat the question? Hopefully, gotcha. Appreciate it. Thanks. Good questions. Any other questions?
So if you're deploying this in a production environment, do people just normally write out every single possible scenario like in there to alert stuff, or is there like?
Yeah, so there's I want to see if I can find it easily for you here. I have one custom rule in there, but there are very many detections that exist already. rather than try to find this live, to make a long story short, there is a significant rule set that exists at a base level already. And a lot of what you can do then is turn it on inside of your environment, see what alerts pop up, and then start tuning it down from there. You know, again, there's a lot of ways to skin the cat with Falco, but 100%. And in fact, by default, Falco is not going to kill anything on its own in and of itself, right? Sidekick is configured to give me alerts here. From there, I need to respond. The whole point is to have real-time visibility into the workloads themselves. But again, like you mentioned, there's rules for detecting privilege escalation, detecting shells that respond, detecting change mods, file system modifications, the things that you typically expect to be, you know, monitoring for. The rule set's there for that, right? And then you tailor it down and make it more specific if you need to.
Talk about show things that like the two. If you want to turn a few alerts on at a time, maybe they're a little noisy, remember that.
Mm-hmm.
If they end up being noisy, you may not want to shut it off per se. What does it look like to tune one?
So it comes
specific instance.
Yeah. So he asked me what it looks like to tune one. I can give you the here, right? You'll get a good look at this one right here. Do so by adding exceptions to the rules that we had. Right. So taking a look at one of these rules here, and if we just scroll down to where it's added an exception, here is where we would go ahead and start tuning things down so that we can filter out these alerts. Again, a few different ways to do it. We want to deploy the daemon set in a different place, have different rules based on whether it's prod or dev. You can do it that way. If you wanted to apply the daemon set holistically, look at the alerts that come through and say, hey, if it came from this specific repository, I know this is not an issue. If it starts with, you know, so on and so forth, right? We look at the fields that come in the actual alerts and we add exceptions based on there. So that's what we do to tune this down. Mm-hmm. Yeah, essentially, right, here's the name of an exception that can be arbitrary. We're going to look at the procs name. We're going to look at the FD, that directory. And if if both are equal to, you know, these sets of values, right? If one's my custom yum followed by user bin, you know, versus my custom app versus the user local bin, then that's accepted, right? So it works in that way pretty simply. And these are just, again, going to be arguments based on the system call. And in this case, this is based on the system call, based on the system call. Yes. Mm-hmm. Absolutely. Was there? Yeah.
You have all those out there in the commission, right? So if you use anything else, you would actually have to do that all.
So if you wanted to reference it, then you would just put it in a macro. Mm-hmm. Yep. You would just put it in a macro, and then it's just going to, you know, you can use it. So I'm sorry. Yeah. So he asked, you know, based on all that we have written in the condition here, you know, would we always have to write this out again every time we have a new rule? And the answer is no. We would just put this inside of a macro. Then we can use that macro as many times as we have to, right? Again, another example of a macro package management process. It's just saying, hey, it's the proc.name inside of the specific binaries. So even this macro references a list. Mm-hmm.
What would be the difference between a macro and a list? I feel like I've seen both.
Yes, you have. I will come over here for that, so you can take a look at some examples as we kind of step through that. So the difference between a macro and a list, it's really just in the application of it. A list is going to be a bunch of values. The macro in and of itself can add logic into it. So yeah, port and so on and so forth. That macro is going to get spit directly into the condition of a various rule, or a given rule, I should say.
So is this is a scripting, right? This is interpreted or is it compiled? You know, at that level.
So that's one that I don't want to lie to you and get back to you on that one. Yeah, so that's a question I want to get back to you on, right? But at the end of the day, you pre-configure these YAMLs, and whenever you do the deployment, whatever you deployed with is static, right? The YAML and the rules associated with it. Yeah, Falco in and of itself absolutely is, and then the YAML associated with it just gets fed into it, so it can reference those rules. Because I mean, at the end of the day, this would be running as, it's like a bare metal environment. It'd be running as a service on a Linux box. It'd be running as a container, right? So it is absolutely a standalone deployment on its own. The YAML in and of itself would be referenced by Falco.
You have a question?
Is Falco providing all the rules? So is Falco providing like a set of rules that, like a standard base? And
Yeah.
then-
So there is a default rule set that's coming off of it. I'll give you an example. This was my one custom rule, and I'm leveraging one of the macros that exists in that default rule set. So there again is a vast default rule set for a lot of different detections, privilege escalation, change logs going on. A lot of things. A lot of the rule set that Falco delivers in and of itself by default. It spawns from things like MITRE. It spawns from things like MITRE, right? Addressing the framework there and the various things we need to monitor for. So yes, there is a verbose rule set that exists without you having to do it.
You had mentioned MITRE. Do you provide the MITRE tag like for your like out of the box thing?
Yes.
I was trying to see if there was an example. I didn't see like if it was referencing numbers.
Yeah, let
tactic
me
and
see if I can't
guys-
find some other rules for you to kind of gauge that. It would come down, I'll just talk through it, right? You don't need to see me dig for things live. Those tags would show up here, right? I have the one crypto tag, but a lot of times you'll see MITRE in there. You'll see, MITRE defense or the specific column of the framework that it's aligned to. So these things will be tagged here again to give you more information about the alerts that come through. So again, that's all in the default.
Will it have the number? Like say like TA, whatever, that's the tactic.
Oftentimes it does, yes.
Okay.
You may have covered this, but maybe I'll. So the daemon is what generates all the telemetry data on the system, right?
Mhm.
And then writes it somewhere locally. Is that factual? Like the telemetry that you're using to trigger off of, I assume the daemon generates and writes somewhere local. There's also a rules engine that runs through that locally. Is that correct?
Oh, okay. Awesome. Y'all been waving at me for a while too. No, but to answer the question, this is all going to be a real-time detection based on what's firing off inside of the environment, right? Let's stay on the system call. It's going to monitor that system call, kind of copy it into user space, right? So we don't do the operation inline in kernel space. It's going to do is copy into user space, and then the rules engine is going to apply to it. From there, the alert generated, it will go ahead and send it out via Sidekick. So if you wanted to really save all of those, again, you'd be using Sidekick to maybe aggregate them in an S3 bucket or do something.
My thought process, just for funsies, asking is if those could be decoupled if I chose to or found a reason to. Say I want to generate the telemetry data with a daemon, but I don't maybe want to use the compute power locally in the system to do the rules firing. I just want to shoot the telemetry over to say Elastic and then write similar detection rules there. Is there a pro or con to doing something like that? Would it be more efficient to keep it locally? Does it really matter? I guess that's why I was asking the question.
I would say that doing it locally would be the recommended way. We want to have these detections locally, again, to have real-time response. Nothing's going to be faster than doing it locally where it happened. So bringing it to the end kind of a philosophy behind it. That being said, as flexible as Falco is, you could just write a very, simpler than my rule here, right? Just something very broad, put a notice on it, and then have them forward it on to Elastic. So you could use it as a tool just to pull telemetry off if you wanted to. It all starts again with having, going back to the circus example from the beginning, having a security camera that can just give you this visibility. Falco is very flexible to then use it however you need to, as much as.
So to follow along, I guess my thought process is to have to do this with like regular endpoint telemetry is if you see something happen, it fires off, that's great. You have that data, that alert data, but if the box goes offline or if there's a new technique that you can now write against, if you have all your telemetry data, whether it's instead of or in addition to, then you can kind of run back through the last week, the last 30 days, whatever you choose, and then kind of look for other indicators or new indicators. I know it's kind of a philosophy question, but that was the reason behind my question is like, great if you find it in real time. What if you actually sleep sometime during the day and you have a small
Right.
team and you wake up? Well, now you kind of lost maybe some of that telemetry because you weren't persisting it somewhere and the box is offline and you just see what you see from alerting and no other telemetry data is usable.
Yeah, absolutely. And that's something you could configure with Sidekick. So coming back to I keep going too far. Coming back to the example here, right? You've got your sensors in place to do that telemetry and detection. This is a very simple diagram because it's very flexible. That collector could be an S3 bucket where we aggregate those things, and should a higher indicator of compromise come up, you'll have that collection there that you can go through and parse. Telemetry, right? It's basically going to be anything we alert on top of. I should take a step back. It will be the alert. It will be the alerts. And what you can do is kind of inside of should have it set up here. Inside of the output of a given rule, you can define what you want to get sit on as well inside of it, right? But yes, it's going to be the alerts that get aggregated. But that gives us, I can say with confidence, that gives us the information that we need generally to understand what's going on for the most part.
Hey, hi. So your policies are based on syscalls. And if I give a syscall, which your eBPF sensor is not recording, is there a way that your eBPF programs can be dynamically changed?
So if I understand correct, if it wasn't, I'm sorry, could you repeat the question?
Your policies are based on syscall. We are trying to use syscalls. These syscalls are being tracked by eBPF programs, right? So if I give a syscall in this policy, which is not being tracked by the eBPF program in your source code, in the kernel space, so can we change the eBPF program? Can it change dynamically?
So essentially, if a syscall is kind of bypassing in a way, can we I'm sorry, I just.
Is it like if the telemetry?
Yeah.
I see.
Telemetry data for whatever reason this call's not being collected, how can you change it? Is something she can go and change, or that's a source code request?
I see. I see.
Yeah.
So there isn't a syscall that it's going to miss. The only way it's going to miss the syscall is if that node is oversaturated, it's ran out of CPU in general, in a containerized environment. If it's ran out of CPU in general and, it's back to doing the workload or doing it, right? Otherwise, it will evaluate the system call as long as that container is up and running and ready. That's driving Falco, where the Falco engine lives. As far as detection on a system call, there may not be a rule in place to do that detection. And in an environment like that, where we don't see what's coming, I would say take the opposite approach. We talked about how here's a list full of malicious binaries. If I see any of these, it's an indicator of compromise. We can do the opposite and let it run for a while, kind of get a good profile of what a container should be doing, what binaries we should see, build a list out of that, and then say if there's anything else, this is drift, right? Alert me on it first. So again, there doesn't have to be any axing response to it. But again, it's visibility into the environment in that way. So as long as the container is ready, correctly and functioning, it's going to evaluate the system calls. It then just comes down to knowing what it is that we just saw, right? The opposite approach if that's more of a black box of what it be. Fantastic question. And I'll also mention too, again, we're staying in the context of syscalls. Obviously the YAML that we're looking at responds to system calls. This is just where we started, where Laura started when Falco, but it's about ingesting any stream source of data. We can write various libraries for Octa logs, we talked about VPC flow logs, so on and so forth, right? So very flexible in that way too. Just want to make that point again, everybody else.
Oh man, ruining the fun. This might be a loaded question then.
Do it. My favorite.
The idea of getting into, instead of like behavior, fingerprinted detections, has there been any development or thought process around anomaly baselining type of detections? Like you may be able to baseline a lot of what's going on, and then for some reason, like Kenny normally does all these things, or in this case, this process normally does all these things, but now it reached a threshold where it started to act not bad per se, but anomalous. Has there been any development or conversation around Falco to do that type of detection?
And essentially that's kind of, in a way, automatically building the list, profiling that container and saying, this is doing something different now on what's going on. So I would say that out of the box, we're not going to have that. Yeah. Yeah, it's so out of the box. I install open source Falco. It's not going to have those types of capabilities. They can definitely be built around Falco, but out of the box, it's not going to have that kind of automatic machine learning capability. I'm going to call it machine learning, right? But
I'm going to steal the last. I'm going to steal the last question. Is that something you would recommend we build into like Splunk, Elastic, or something like that to start looking for all the alerts?
Absolutely.
What we're getting. Okay.
Yeah. I would treat this again as the security camera, as the visibility engine, and then to add more functionality on top of it, right? But it all starts with having the detection in the first place. It's a tool there to do it.
Awesome. Well, we are about out of time. Charles, thank you so much for the awesome presentation. Let's give him a round of applause. So for everybody watching online, thank you for joining us. If you do have questions, still feel free to post. Go to our Discord. We post them there. You can get in touch with Charles as well. We can pass those questions along, get you some answers. So thank you again for joining. We are DevSecCon. Have a good one. Thank you all for coming. Appreciate it.